So we are going to discuss regarding the secrets and HPA. What is the concept of HPA? Is a horizontal pod autoscaler. What is this? Horizontal pod autoscaler. Next one is CA, cluster autoscaler. So HPA will increase the pods. Cluster autoscaler will increase the HPA is horizontal pod autoscaler. So it depends upon the load. Automatically we can increase
Pods.
parts. But if more parts are running in the backend, we require more nodes also. So who can scale up those?
Cluster autoscaler.
Cluster autoscaler. But on premises, it's not possible. Only in the cloud itself, cluster autoscaler is possible. So more number of nodes we can increase. And what is the purpose of using the secrets?
We can encrypt any data.
We have multiple environment values we need to pass for different environments, but it contains sensitive details. If it is non-sensitive details, how we are going to pass?
Config maps.
Yeah, if it is non-sensitive details, we are going to use this config maps. But here, if it is any sensitive details, we have those details are going to store in
Secrets.
the secrets we are going to store it. Okay. So what is the purpose of secrets is we have a maybe password is there, otherwise token, key, certificate. That's if someone sees like there is no security for that. Okay. So that is the purpose. We need to encrypt the key and need to pass that key in an encrypted format. Then even if someone sees also, they can't decrypt that one. Okay, so that is the purpose we are going for secrets. The further purpose we are going for the secrets. Okay, so now we'll go for just like config map itself, but in the we need to create a secret in a encrypted format. We need to create. So now here, using the kubectl, we are creating a secret. Okay, see by default our username is admin and this is your password. But we are going to create a secret. Then see here in the special like these codes we are going to use. Otherwise, another one is you can save this one into one test file. Okay, so instead of directly passing here the username and the password, we saved that output redirected to another file. So what is the name of the file is username.test, password.test. From this, we are going to create either kubectl directly. We can give the username and the password. Otherwise, we are going to give the okay. Once we create these secrets, kubectl get secrets will give you the what are the secrets we have under that particular. The secret is not a namespace kind of resource. That's not the scope is. If it is a pod or deployment services, these all the scope is namespace. But secret is a cluster level resource. That means not only in one particular namespace, for the multiple clusters also we can work multiple in the cluster level for the multiple namespaces we can use the secrets. The kubectl get secrets will show us what are the secrets we have. But once we got the secret, we need to use those secrets in our pod. In our pod, we need to use those secrets. So once we create the secret in the pod, we need to attach it. Here they created one secret. And here we are going to encrypt using opaque is the encryption algorithm. Okay, so by default opaque is the encryption algorithm. Using that, we are going to encrypt the details. The default is secret type supported by Kubernetes. So what is the problem if I keep the secrets in my Docker file itself?
It
If I
will
keep
expose.
Docker file, everyone can see it, and they have their own passwords, all those. That is the reason it's not recommended to keep that in the
Docker file.
in the Docker file. We shouldn't keep it. Okay, so we need to save like a our own environment variable itself. We need to pass here. We are passing those all those as the all those we are passing as
Environment variables.
already the TLS secrets also. When we use the TLS secrets is whenever we are going to use the TLS termination, we'll have the certificates under the ingress level. We are going to create a secret and the TLS certificate we are passing in the TLS certificate we are passing in the in our ingress rules. We are going to configure the TLS. In the ingress rules, we have configured our ingress. So like this also we can attach the secrets. And once we create the secrets, we can attach it to the pods. Using kubectl or as a file also we can create. The get secrets, all these once we done, just like how we have attached it to the config map. In the same way, we can create those to the pods. Okay. Otherwise, in the Helm chart also. In the charts also, we'll have the secrets in the templates folder. If you go to the templates, in these templates, what are the manifest files they have? Okay, say pod, deployment, okay, extra list, ingress, config map. So in this, what are the secrets we are passing? We'll see. So here we have secrets data YAML. So for all these, who is going to pass the values? Who is going to pass the values for this? Who is going to enter the values? So from the values.yaml file, we are going to pass it from the values data. So now here, so this is the variable. Whatever the value you want to pass. Okay, so from the values.yaml itself, we are going to pass it. So try to understand now. So here we have these all the manifest files. If we go to the Tomcat, here we have values.yaml. In the values.yaml file, whatever the number you want, what is the image it is using? 10.1. In the Bitnami Tomcat itself, this is the version. If you don't want this version, you want a latest version, then give the tag is
Latest.
Latest. If you are using the registry, what is that docker.io means? What is that docker.io? That is Docker Hub path. If you are using ECR instead of Docker Hub, then give the Docker Hub like ECR path you need to give. Okay. So what is that pull policy? What is the meaning of pull policy is? Okay. Some companies will use always pull it. Some companies will specify pull policy is if not present. What is the meaning of if not present? Locally, if I don't have image,
Then it will pull it from the.
then it's going to pull it. If you specify always, whether we have locally or not, again it tries to pull the latest one. Do you understand? So try to go through all these, whatever this we have for the, okay. Now here, what is the Tomcat password we are passing need to be passed as a secret. So whatever the Tomcat password we are passing, here we need to say Tomcat user they given as user. Once you pass this Tomcat password, here this Tomcat password here we are going to pass this. Say username also we are going to pass, but here we are going to use the secret. Okay, say here in the secret the data Tomcat password is going to encrypt into those. Okay, so what are these variables is, say if we go for the deployment, normally deployment.yaml, say here whatever the values you are giving, so that namespace where we are giving, assume in the values.yaml, okay, I'll give namespace is, this is the namespace. Okay, release.namespace. Okay, how many replicas? In the values, I'll give replica count. Okay, if I give namespace equal to one value, I'll give replica count. I'll give one value. Where I have given all these values?
Values.yaml.
Values.yaml. But these values, this variable has been declared here. Then this namespace here will get. And API version, we already given that one in the chart.yaml file. What we have given in the chart.yaml file, that is going to pass those details. Okay. So then, whatever the replica count we have given, everything we are giving in the values.yaml, from this deployment is going to work. And if we give another one, then from there we can give config map and secret values also we are passing from. But when we are passing the secret, encrypt it and send it. Encrypt it and so now this is the password you want to set. You run this one, then you will get this output. Okay, then this password we need to use in the this string we shouldn't keep birds rental real. This we shouldn't keep. We need to encrypt it. Then we will get this output. This one we need to keep in our password column. Okay, then it's not possible to decrypt that one. It's not possible to decrypt. Directly don't use the here this password YML something is generated, right? What is the password actually? Birds rental rent real is the password, but we have encrypted that to this column. This one we are passing, but in Helm chart what we are doing is instead of using in the secret file, in the values you pass that as a secret. Then by default that's going to be decrypted. If it is a config map, If it is a config map, directly you can use the value. But if it is a secret, we need to encrypt. We need to encrypt. Okay. So otherwise, how we can encrypt is using the kubectl command also we can encrypt. So now here we need to convert the strings. Then we got the outputs. So from this, we are creating a secret. Okay. In an encrypted format, we are going to use those. And once we create the secrets, those we are going to attach to the parts. Those we are attaching to the parts. Okay. So if we encrypt, what is the advantage? Even if someone sees also, they don't know the actual
Password.
password. So that is the reason directly instead of giving the username password, here we encrypted those. Okay, so that's we encrypted using base 64 encryption, and that keys we have used. Even if you have the certificate also in the TLS termination, we need to use the certificates, and in the values we are going to give those encrypted format. Then secrets already we have in your templates folder. Config map secrets, all those we have in the template folder. That is the reason. Just go through the Helm charts for Tomcat. We may use MySQL, Postgre you try to use. Say here one more scenario is we have MySQL, Postgre also can be running as the parts itself, but AWS recommends to use them as RDS. AWS recommends to use them as
RDS.
RDS instead of
Pods.
in the Kubernetes. Better to go for the managed service. They will tell. Okay, so better to go for the managed services. Okay, but even we can run as them also. Try to deploy for the dev and QA. We are not using RDS. We are using as the pods itself. So mostly MySQL, Postgre, MongoDB, these all we don't use as deployments. We'll use as
Managed service.
no. Deployment, stateful sets, daemon sets, which is the best one for the databases.
Daemon set, sir.
No. Daemon set means in each and every node, one database would be running. It's not recommended like that. We need to run as a stateful sets only. We need to run them as
Stateful set.
stateful sets. MongoDB, all these also need to run as the stateful sets. Okay, then go through ELK. ELK is a stack of three resources. One is Elasticsearch, Logstash, and Kibana. Okay, so we have three things: Elasticsearch, Logstash, and Kibana. These all the three combinations is called as ELK. So why we will use ELK is like in order to collect the logs. Say in each and every node, Logstash need to run. Then Logstash we are going to run as Logstash we are going to run as daemon set, deployment, or stateful set, which is correct.
Stateful state.
No, it runs on each and every agent or node. If it is want to run on each and every node, then how we can run it? We need to run that only log stash. We need to run as daemon set. Need to run as daemon set because it need to collect the logs of each and every node also. Okay, then log stash will collect the logs and stores in stores in stores in Elasticsearch. Elasticsearch. Okay. Once it collects all the logs, if I have 10 nodes, from there it's going to collect the logs and stores in the Elasticsearch. Okay, it's a centralized kind of collection. Okay, so then we need to visualize it. The graphics, all those like metrics, all this we need to show visually. For that, we have Kibana is the dashboard. Okay, so what are the three components we have? ELK, Elastic Logstash, and Kibana. Instead of this, here we have Elasticsearch, Fluentd, Kibana. This stack is called as EFK. Okay, so we have ELK or EFK. Other than these, some of the companies are using Splunk also. Okay, say Datadog. So these are the logs and monitoring kind of tools. And for Kubernetes, so these are the logs means which logs? Mostly the application logs. But at the Kubernetes level, we have Prometheus, and the Grafana also we have Prometheus and Grafana. So Prometheus having one component like a node exporter, it will collect the logs from all the nodes. Okay, and stores them in like in the Prometheus. And who will visualize them is Grafana. For Kubernetes monitoring, we'll use Prometheus and Grafana. Whereas application logging, the application logs are very, very important for the developers to troubleshoot. Application logs are very, very important for developers. Say, suppose if any issue is there, definitely they need to check the logs. And monitoring team also would be continuously checking any errors are coming like this as the prevention kind of thing also. So the logs we are going to get it from ELK. And Prometheus and Grafana we are using for Prometheus and Grafana we are using for the Kubernetes monitoring can be done. Kubernetes monitoring can be done through. Okay, so then we may have Kafka. So these all we are deploying. How we are deploying on your Kubernetes clusters? You should tell the Helm charts. That's the reason. Just go through before itself. These are the Helm charts. Even we have Hadoop related also. Okay, so these all as of now in our environment we are running as mostly we'll have Node.js related also. But instead of using that image in our real time, which image we are using is we are creating a multi-stage Docker file. From that multi-stage Docker file, we are going to build it. Okay. So, and for the auto scaling, say in the microservices, it's a very dynamic kind of environment. The load may be coming sometimes very vast load may come, sometimes low load. Automatically, we need to decrease the parts. So for this, we have the HPA. What is that? So using kubectl, autoscale is one command is there. using the auto scale, we already created some parts, minimum, maximum, like this we can specify. And if the CPU utilization is 80% or 50%, then that minimum number of parts are getting created first. Okay, so later, based on the CPU has been reached, we can scale up or we can scale up or
Can scale down.
scale down the resources. Based on what metric we are going to do it?
kubectl autoscale.
That auto scale is nothing but it's going to create a HPA. That's going to create a HPA. HPA stands for horizontal part.
Autoscaling.
In our scenario, what I said, the condition is
If it is 80%, then it is
CPU is the one of the metric. Like this, we have a lot of metrics we can use. So we can specify the lot of metrics regarding the object is going to scale up. So now here in this CPU utilization, like that's we created through command, but this is what is this? This is the YAML code. So we can create a metric also. And we can work on the metrics also, different metrics. By default, CPU like this we are going to use. Yeah, so kubectl auto scale deployment degree hyphen minimum is 2, maximum is 5, CPU percentage is
80%.
like this we can specify. So instead of creating like that, we are going to create it through here we have a deployment. Once we create the deployment, we are creating a auto scaling. Auto scale deployment, CPU percentage is
50%.
minimum,
One.
maximum. Okay, this PHP hyphen Apache is the deployment which you have created here. Deployment name is PHP hyphen Apache. So that's we are going to create. But instead of creating like this, say if you get the kubectl get HPA, say it shows okay. So now we have only minimum one pod because that pod also doesn't have load. If this reaches 50%, then it goes to 2 pods. If both the 2 pods also got 50%, then third pod would be
Created.
okay. So now they're increasing the load. Then they updated to how many pods here?
7.
7. So they generated some load on that. Okay. So then
Sir, I have one question.
yeah.
Like after 50%, like how it will going to know that it will going to create 1 pod or 2 pod?
No. Maximum how many you have given, accordingly it's going to create.
No, like my doubt is like after 50%, like it will create only 1 pod or 2
Pod,
pod.
it creates 1 pod.
Only 1 pod. That one we are mentioning, or it will like
No.
by default?
Automatically it's create 1 pod. If both reaches again 50%, then one more.
Okay. So at a time only 1 pod after
1 pod would be created. Okay. So then here, can you tell me what is the metric? Okay, what is the metric here? Packets per second. More IO coming to
Pods.
parts. What is the value they given here?
1K.
1000. Okay, so 1000 like packets per second. If it is comes, okay, then we are going to increase
Number of pods.
the number of parts. That means not only CPU. They may ask you to ask some more.
Input value also.
Some of the other metrics we can use in the HPA. In this scenario, we use the metric is
Input, coming input.
the packets per second. Packets per second. And request. How many requests are coming in the ingress? That means 2000 requests. Maybe from the 2000 users, we got the
Request.
request. So what is the metric here?
Request per second.
Request per second.
Request per second. Like this, we should able to tell 4 to 5 metrics names. And here they use multiple metrics also. If any of that reaches automatically,
Pod will be increased.
pods are getting increased. And the request we are not checking at the pod level. We are checking at the ingress level. That means overall my application 2000 hits came, then I'm increasing more pods. And based on the HTTP request. Okay, even from the Prometheus also we can collect. From the Prometheus metrics also, we can perform autoscaling. Okay, so what is the difference between HPA and cluster autoscaler?
In HPA we can like mention more configuration kind of thing, like if it
More
is
parts are getting created. Cluster autoscaler is what is the cluster autoscaler? More number of nodes can be increased. Say suppose assume I thought of maybe only 80 nodes. Sorry, 80 pods maximum. We went for maybe around 4 nodes. But now HPA increases total, not for one microservice, maybe multiple microservices, 80 pods to 400 pods. Now, 4 nodes may be not enough to run 400 pods. Those may be all maybe crashes. Cluster autoscaler will identify more load on the nodes. Will increase more number of nodes. So nodes may be increased from 4 to 10 to accommodate this, or maybe at least 6 to 7. Okay. In local on-premises cluster autoscaling is not possible. Only in cloud managed Kubernetes it's possible. That means normal if you have a VMware or physical servers on top of that, if I have the Kubernetes, it's not possible to do automatically increasing more number of nodes. We require definitely cloud-based itself because elastic kind of features comes with cloud only. That means with EKS or AKS or GKE only we can do the
Autoscaling.
yeah, which autoscaling?
node.
Cluster autoscaling. Cluster autoscaling can be increased. Okay. So then, what are the probes we have? What are the probes? So we have three types of probes in Kubernetes. What are those? Liveness probe,
Readiness.
readiness probe. Third one is
Startup group.
startup probe. Okay. So in the same way, the people will ask us one more scenario also. This one, node selectors or node affinity rules, anti-affinity, bad affinity, taints, and tolerations, PDB. Okay, support deception budget. Then I have a 4 nodes assume. One node having an issue means I need to bring it into maintenance mode. Okay, so here do you understand? I have 4 to 10 nodes. So all the kubectl commands just go through once. Okay, we have drain and uncordon. What drain will do is, say suppose assume we have a road, if it is under repair, they'll keep it under maintenance. Say that, then we can't go to that road. In the same way, one node having a maintenance activity. That means all the workloads, I don't want to run it. Then before doing the maintenance kind of activity, what we need to do is kubectl get nodes will show you all the nodes. Which node we want to drain, give that node name or ID using the command kubectl.
Drain node.
Drain that node. Then that will new workloads, all those doesn't goes to
That
That
particular
specific
node.
that particular node. Okay, so most of the workload will goes to the new other nodes itself. Once your work is done, once your work is here, how much grace period they're giving?
900.
15 minutes.
15
After
minutes.
15 minutes, we are bringing into maintenance. Okay. So once your work is done, what is the command you need to do is uncordon. Uncordon will do like again it's available for us. Once our work is done, we'll remove all those, right? Okay, then that is schedulable. That means the workloads can be running on that workloads can be running on the
nodes.
nodes. Okay, so that is the purpose we are going to use uncordon. So whenever any maintenance activity is there, we need to use these commands. So here one more basic command is there, cluster info. Basic cluster info we'll use every day. These all the commands just go through once. kubectl cluster info will show you more information about your cluster. Okay, so what are the mods are running and any events are happening, all these also we are going to get it. And can you tell me what is kubectl exec?
Execute
kubectl exec to enter inside the
pod.
pod. So what is the command is kubectl exec pod name -c if any particular command is there, and we can run the bin bash kind of command. Bin bash, we can enter inside the,
Docker, sir.
and in the same way Docker logs will show us okay, so here we have kubectl logs. So if any logs we want, -p that pod name. Okay, so then -c that container name. -p is for pod. One more we need to add is -n that namespace. Okay, and what describe will do is in the Docker we have inspect will shows more details. Here inspect also will give you the detailed information regarding. So hence for the basic troubleshooting, first we need to do the cluster info, describe that resource, logs. Okay, the logs, and enter inside the pod using kubectl
EXE.
Describe. Exec.
exec. Delete the resources, exec, expose, get also will get the details, what are the resources we have. Run is to run the, like any of the parts like that. Okay, scale to scale up the deployments, those. So these all the resources we are going to use. Go through the commands also. Cluster auto scaling will do at the EKS level. Okay, so then we have these resources need to be created, like node selectors, node affinity rules, pod affinity, paint and tolerations. So whatever we are discussing now, these are the mandatory questions in every interview. So that is the reason we need to have more theoretical knowledge in all these. Practically, we need to deploy the Helm charts and the kubectl commands, and how we will troubleshoot for the issues. Those all we'll discuss. Go through the kubectl commands also. Even in Katacode also, you can practice these all kubectl commands. Practice more kubectl commands and Helm commands also. Okay, and try to provision EKS cluster through GUI. Go to AWS console and try to create the EKS cluster. That is very easy to create. Okay.